E-mobility has won the race. It is the only solution to reduce mobility emissions fast. 5 years ago, we decided to build a single platform for electric cars. Many in the industry questioned our approach at that time. Today, they are following suit, while we are reaping the fruit. Our group models account for a quarter of all BEVs sold in Western Europe and are conquering market share around the world. E-mobility is the key pillar of Volkswagen's forward strategy. In the next few hours, we will present to you our power roadmap, the most important lever for electric mobility. We will take a holistic approach and expand our e-mobility value chain. Our goal is to secure a pole position in the global scaling of batteries. We will make charging as easy as fueling by strengthening our charging network in Europe, the United States and China. And we will combine mobility and energy management. Power will become a new core competence for Volkswagen and an integral part of our platform strategy. With 10 million cars a year, we know how to use platforms and synergies to transform a business successfully and unleash value. We have been at the forefront of e-mobility across the world, both in terms of technology and in terms of scale. Now we are applying the same principle to battery technology. We will focus on one standard battery. From 2023 onwards, we will be ready for rollout. By 2030, one cell format will cover 80% of the use cases within the group. The one-size-fits-almost-all cell design and high scales will radically reduce battery costs. In our entry segment, the unified cell will bring down battery costs by 50% compared to today. Lower prices for batteries means more affordable cars, which makes EVs even more attractive for customers. And we are taking an end-to-end approach. Our first battery recycling station is already in test mode. We have researched, piloted production, and are now on par with many suppliers. The new EU Green Deal means that our BEV share will double to almost 60% in 2030. Battery capacity needs to grow in parallel. For us, this means an additional demand of about 240 gigawatt hours in Europe. That's why we are taking action. We are planning to operate up to 6 gigafactories with 40 gigawatt hours each across Europe, on our own and in collaboration with partners. We are reducing the costs for batteries, thus reducing the price for electric models. And we will make charging as easy as fueling by taking high-power charging to the next level. We will multiply the number of fast charging points in Europe by factor 5 over the next 4 years, together with partners to cover 1/3 of the demand by 2025. In the US and China, Volkswagen is building nationwide fast charging networks. We will create the largest public high-power charging network. Additionally, we are combining mobility and energy in an innovative way. The electric car will become an integral part of the future energy system. Electric vehicles will become mobile power banks. They will bring the green energy transition to a new level. It will be possible to manage energy in and around your house in a smart way, reducing costs for the customer and optimizing the grid. Now, let me hand over to my colleague Thomas Schmall Thomas has built an impressive transformation track record. He has successfully electrified Volkswagen Group Components, our components business, which alone is a company with 80,000 employees. He has just joined our group board and now heads up the powerhouse for our e-mobility ecosystems. Thomas, the stage is yours. See you again later.
Thank you, Herbert. Ladies and gentlemen, welcome to the Volkswagen Powerhouse. The Volkswagen Powerhouse, it's a technology division inside Volkswagen. We have two main pillars. The first main pillar, on the left side, you can see is the battery cell and the battery system. On the right side, you see the second pillar, charging and energy. These are the most two game changer inside the EV world. Let us start with the left side, battery cell and battery system. The first challenge for a big OEM is scale. In the EV world, size matters. That means you need to find a way to have huge volume over a big spread of product portfolio. That's the base for everything in the EV world. Based on that, the second challenge will be the technology roadmap. Which technology you are using. Be right in time and for sure the price, hitting the price targets. There is in the EV world need for speed because we need ramp up fast. So you have 2 points where you can accelerate. The first point is organizationally. You need put all responsibilities together in one hand. This is the reason why we call this closed loop. We are not working longer with this new division of Powerhouse in segments or in pillars inside the company. We have one hand, one responsibility looking to the closed loop in total. That means we have the battery cell, the battery system, the first use, the second use, we will explain later, and for sure the recycling. If you have the structure based in, what is the next? The next is the technology roadmap. We have a fundamental mind change inside our company. We are not looking longer to a current approach, making cars and defining out of the cars the batteries on the battery system. We will put the battery in the middle of the heart of our development of cars. This is a major cost point in the EV world. If we have the volume and we will roll it out, we need put it in the middle, in the center of our cars, and then defining the cars around the battery. Sounds easy. How we do that? We're calling that the unified cell concept. You probably will see 4 times the same design of a cell on this picture. But the intelligence is inside. You have not a unique cell. You have a format, a design, what is similar overall, but we are different inside. How this works, we'll explain you in some seconds. With this concept, we are really able to put 80% of a unified cell in our cars. 20% for sure, a big OEM as Volkswagen need specific solution, independent from the cell design. That can be a prismatic, a pouch, or a prismatic cell. It doesn't matter. Major important is that we have the 80% based on the same design, on the same format to achieve economies of scale. When we start? We'll start in 2023. It's more or less tomorrow with this unified cell concept inside the group. The rollout starts in 2023. And then ramping up, we will achieve in 2030 the 80% I promised you. With the 80% on the base, we can make a huge cost focus. We are reaching our cost targets in the volume segment. That means we will be 30% less than today in the cost of a cell in the volume. And we have on top the possibility to achieve a 50% cost increase in the entry segment. As you can see, the intelligence is inside. We need to talk a little bit how this works. Coming back to the closed loop, the first point in the battery cell is the chemistry. I like to Welcome, Frank Blome, on stage. Please, Frank.
Thank you, Thomas.
Frank, before I hand over, promise me to make it not too complicated, please.
I will try.
Thank you.
I will do what I can. Thank you, Thomas. So let's get into the inside of the battery cell. That's the chemistry, basically. We do have an entry chemistry with iron phosphate. On a long-term base, we see high manganese content for the volume vehicle segment, and for specific solution, high nickel, manganese and cobalt is important because high nickel means high range, high performance. The end game out of our point of view is solid state. Before I get started, I have to explain a bit what a lithium-ion cell is. We see the anode, very simplified view, a separator, the electrolyte, and the cathode. The anode drives the charging very much. The cathode drives the range and the cost of the battery cell and the battery systems very much. Let's get to the cathode. The cathode is the control lever for sustainable supply chain, cost and range. Here we see the state-of-the-art technology. The chemistry today typically used in all electric vehicles is nickel, manganese and cobalt. That defines the cost of the cell by 40%. I don't think there's any other layer into the car what defines cost that much. And also the range comes out of the cathode by 90%. Getting to LFP. LFP has a big cost advantage, a slight range disadvantage. Iron phosphate, that's LFP, comes without any cobalt, nickel and manganese and is a very robust technology. The cycle stability is very good. That means especially for cars with low range, this is a very promising technology. High manganese cells. That's a long-term, out of our point of view, very promising technology because it's cheaper. Nickel content is lower. Nickel is quite expensive. Cobalt is too. There's no cobalt any longer in the cell. And the range is on the same stage than the cells today, the state-of-the-art technology. Let's get to the anode. As said, the anode is a control lever for charging performance. If the anode is charging, all the lithium has to go into the anode. That's why it's 100% performing the charge time, the charge performance. The anode also has a chance to improve energy density and with that range by 10%. And that can be done by synthetic graphite plus silicon. If we get silicon into the anode, we have a better range. It's plus 10%, and the charging time performs better too because the silicon can connect more lithium ion than just the graphite. We do have it in production. The Porsche Taycan and the Audi e-tron GT are using that already, and they are the benchmark for charging time in these days. Now I'd like to talk about solid state. Again, this is the end game for battery, lithium-ion battery cells. The simpler design leads to higher performance and lower costs. We start again with a more concrete sketch, a more detailed sketch of anode and cathode. So the anode content is copper and graphite, separators in between, electrolyte is there, and it's fluid electrolyte to make sure the lithium ion can move between the two parts. Cathode is on the other side, content in this case is NMC and aluminium. Coming to solid state, here we see that there's no graphite any longer, no liquid electrolyte. Separator is the key of success. That's containing the solid state technology, making sure that the lithium ion can go in one and the other direction. And with that, we have an improvement of weight, of cost, and of charging time. There's no barrier any longer as graphite or silicon for charging. And only the anode today in an ID3 with the biggest battery is 100 kilogram. We can get rid of that weight too. That means the charging time can be less than a half compared to state-of-the-art technology, and the range will be plus 30% because the cell has less weight, is easier and simpler. I want to prove that with data. Here we see data from our partner QuantumScape. The solid state battery will come in now, and you see that a solid state battery as we have it now, and a 10 to 80% is a typical charging with high performance charging. Here we are at 12 minutes already. That's a proof of concept for the technology. A standard state-of-the-art cell today is between 35 and 20 minutes. So faster is always better. That's a big thing we made here with our partner QuantumScape. And of course there's still a lot to do to industrialize the technology, but the proof of concept for the design we see already here. What does that mean in reality? In reality, we just took out a few examples, 450 kilometer or 280 miles range from Los Angeles to Las Vegas, for example, Leipzig to Munich, or Beijing to Dongying. And that has to be done today with a charging time of 25 minutes. 25 minutes is not too bad, but we are planning to get to 17 minutes until 25, and with solid state technology after 25 we are able to do it in 12 minutes. So that's a big advantage and will help the customer to adapt the technology also to long distance drives.
The main three processes are the production of the electrodes, the assembly of the electrodes, and then the finish. The next step you can see here, it will be the dry coating process. The dry coating process means what? All the light ones in the background, all the single processes, you can cut off the process. That brings you to what? That brings you to a 50% decrease of production area, to a 30% decrease of investment, and to much better CO2 balance sheet. That means you can, with a better CO2 balance sheet, more or less double the output of existing site. What is a dramatic step in front? Now the big question is, after the dry coating process, and you put out all the steps, how you can make the process much faster. How you can stack as fast as possible the electrodes. For that, we prepared a small film for you. Here you can see something you will recognize. Now you see it more or less what it is, and now you know it. It's money. This will be the benchmark for us to stack electrodes. We like to come to the same speed of stacking electrodes like you can see here for money. This we will aiming for, and this we will realize. That means you will be really, really fast. After the stacking of the electrodes, the next step will be to come from the cells to modules to battery system. For that, I'd like to invite Frank on the stage because he will explain again how this will work and how will be this in the future. Frank, welcome on the stage, and please again, don't make it complicated.
Thank you, Thomas.
Thank
this
you.
time it's easier. This time it's much easier. So, I'd like to talk about a simulation we prepared, an animation where we see the battery system, and thanks to all our engineers preparing this, I really like this animation you will see right now. Today we have a cell to module system. That means the cells become a module, the module is getting into the system, and that's a battery. The next step is cell to pack and cell to car. With cell to pack, the cells are getting into the battery system directly. The battery system then is a complete entity and gets into the car. For cell to car, it's even further advanced. For cell to car, the cells go into the battery cabinet, and the battery system is part of the integrated mechanical design of the vehicle. Here we see the comparison between today and the future. The less complexity gets to better cost, better weight, and better volume of the system, and with that we get to higher range of the vehicle.
We as Volkswagen are taking this really seriously. Recycling, we invented a process we are calling hydrometallurgy process. With that process we can recycle 95% of a cell. 95%, that means more or less only the separator you cannot recycle. The rest, we have the opportunity to bring all minerals back in the first step to make a cell. Here you can see how a cell will be in the different minerals divided. You can see it, and you see all of that, more or less also the separator, we will recycle with our process. We started the recycling process in January 21 in our plant in Salzgitter. It's the first plant we installed a machine like that. And how this works, we will show you in a small film. The main three advantages you can see here. We have one ton more CO2 per vehicle saving. We have for sure it's clear a sustainable effect as we are recycling the material. And the customer will benefit of the increase of the cost fall. We have lower costs because we are able to use the minerals out of the cell again in the same process. That was it from the closed loop approach. You can see all three circles we had been explained again. And after the closed loop, what's the next? The next step is the localization strategy. How we will localize volume in Europe as a short view. Wow, that's nice, I like him. You can see out of the Green Deal, the share of the EV cars will increase for Volkswagen only for Volkswagen, from 30 to 60%. We will double in our volume scenario, actually, we have the EV share. That means what? That means the demand of 240 gigawatt hours only for Volkswagen in Europe. Or you can translate that in 6 plants or 6 sites with 40 gigawatt hours. And again, that's only the demand from Volkswagen. So, how we do that? The first step will be our plant with Northvolt together in Sweden. This plant, this site will come with start of production in 23. It's also more or less tomorrow. We changed a little bit the approach in the last weeks and months because what is the new story behind that? The new story is a new setup. The actual setup was that we have actually planned to make on 2 sites, in Sweden one and one in Salzgitter, more or less 30 gigawatts, 2 sites, same cell. Now, new step will be that we will increase our gigawatt hours for Northvolt in Sweden. We will go up in the end for 40 gigawatt hours only in the plant in Sweden. We will have only one project team, only one location, and all resources bundled on that in Sweden. In Sweden, we will do the unified cell for the premium segment. On top, to speed up and to make it real, we like to install a 40 gigawatt plant in Salzgitter with a different cell format. This will be the unified cell for the volume segment. That means we are 2 times higher in volume. We have, instead of 40, we have now 80. And that gives you more volume in much faster time. We will have, in a summary, a cleaner project setup. We will bundling the resources. We will have less complexity in the process. We have a faster ramp up. And finally a higher volume output. As we like to go for start of production in 25 in Salzgitter, this plant will be managed by Volkswagen. It will be the plant for the volume segment of the unified cell. To start in 25 means you need move ground. Here you can see our Salzgitter facility, and there you can see the new cell plant we like to do there. This is a huge ground movement. We will occupy around about 100,000 square meters in Salzgitter plant. And it's a perfect symbol for transformation. Salzgitter was the heart of our combustion engines. We are transforming this plant in a new technology. We're transforming it in the future. We make the future happen in Salzgitter. And how we do that with the people, I like to hand over to Günther Mendel, to our Center of Excellence in Salzgitter. Günther.
Welcome to our state-of-the-art pilot line opened 2 years ago. With around 450 employees and additional international locations in China and the US, we have concentrated the cell competence within the VW Group. We focus on future technologies for products and furthermore for innovative manufacturing processes for large-scale production. Together with our partners, we create the batteries of tomorrow. The cell production can be divided in 3 parts: electrode production, cell assembly and formation. The first step is to produce the electrodes, the anode and the cathode, coated aluminium and copper foils. The coating material is the most valuable asset in an electric vehicle and determines essential the properties for charging, power and range. Those foils have to be stacked with the separators between to make the cell stack and place it into the cell can. During the formation steps, the cell will be activated by charging and discharging several times. Here you can see the completed cell. To build up know-how in Salzgitter, we have invested 100 million euros so far. Moreover, we plan tomorrow's factory, which will be located right next to this building. And now we will have a look inside to our new innovative laboratory. I hand over to my colleague Jörg.
Thank you, Günther. Indeed, this is a public premiere of one of the most advanced cell labs in the automotive industry. Here we dive deeply into the cells and unravel the key factors of performance to ultimately design the cells for the future. In our cell development lab, we develop the cell chemistries to fulfill the needs of our customers. Innovative materials and speed are key to reach our goals. Therefore, we develop anodes and cathodes in parallel on distinct lines. And the most promising designs will then be transferred to the pilot line. Our analytical lab is dedicated to support the development and quality assurance. We have a complete set of state-of-the-art devices and even cutting-edge devices. We can see the lithium in our cells through a very powerful scanning electron microscope. And just a few of its kind are in use worldwide. So we can fine-tune the cell designs and understand underlying mechanisms. Here where I stand, we do performance testing. The test field is highly automated and energy efficient. One of the most important tests is fast charging. On screen, you see a test run of a cell in an early stage of development. The results are very promising. Fast charge to 80% is possible in about 12 minutes, and this is close to our goal of 10 minutes. And for the customer, this would already mean cutting charging time in half. So much for now from the labs. Bye and back to Günther.
With the expansion of the Center of Excellence, we have set an important milestone for our future battery cell strategy. We therefore make sure to offer our customers the most attractive electric vehicles. And with that, I say goodbye from the Center of Excellence in Salzgitter and back to Wolfsburg.
Thank you, Günther. Thank you for this nice explanation out of Salzgitter, our Center of Excellence in Europe. After Europe, we will have a second Center of Excellence in China. More or less the same impact. And then we come to States. That means we will triple our Salzgitter Center of Excellence. We will have 3 times worldwide a Center of Excellence. Back to our site production in Europe. What we are doing here. I explained to you the first plant 23 will be Sweden. The second plant will be Salzgitter. Where will be the third and the fourth plant? You can have an idea more or less here on this picture. The third plant we like to do in Spain, in Portugal or France. It depends where we get the best setup in the region. So we have opportunity in the south of Europe to make the third plant. And the fourth plant we will do in Eastern Europe. We don't know until today if it will be the Czech Republic, in Poland, or in Slovakia. We are discussing with partners, with governments, with the European Commission, where it's the best place to install the fourth plant. And on top, until 2030, we'll make 2 additional plants. How this will come to financing, you will see the next chart will give you an idea. The volume in the area with the 2, with the number 2, it's a new volume I'm discussing and telling it to you. This is the volume we need 240 gigawatt hours. So we are in discussion how much you need to in-house and what we can do with external key suppliers. The first 2 plants, Sweden and Salzgitter, are matching perfectly in our planning round until 25. As you have seen, 25 will be Salzgitter. What will happen after? This we are in deep discussion. We have our strong financial targets, we stick to. But if it's strategically necessary to increase our engagement in battery cells and battery manufacturing, we are capable to expand that. A little bit back, down to earth costs. We explained to you about chemistry, about supply chain, about production. And I told you we will achieve a 50% decrease of cost in the entry segment, in the volume segment, 30%. Where it comes from? 15% will come from the cell design. 10% will come from the production process. This is the dry-coating process. 20%, the major part, is from the raw material inside the cell, and 5% will be the battery system concept as cell-to-car, cell-to-pack. This is a split how we will achieve the 50% or the 30% as we had shown to you. The key takeaways out of the first session. We as Volkswagen, we have a clear technology roadmap. We know that we will achieve with a unified cell 80% of product portfolio, what is the base for everything. On top, the 20% can be cylindric, prismatic, or pouch. We can define it because 80% are our baseline. We achieve the cost targets to be on a competitive level. In the last days and weeks, you have read a lot of information from the external analysis confirming that we are actually today competitive, and we will improve it further. We installed a closed loop responsibility to speed up every activity for the cell. And we have a really, really solid localization plan for the top 2 plants in Sweden and Salzgitter, and the other ones will come soon, until 2030. This was the first session about cell and battery system.